Hello friends, welcome to our channel The Mechanical Engineers Team. I'm Jagdish. Today's topic is IES, Indian Engineering Services. So in today's video, I'm going to explain a thermodynamic numerical problem which had appeared in the IES paper 2009. Okay, so let's begin. First I will read the question. An engine working on Carnot cycle rejects 40% of absorbed heat from the source, while the sink temperature is maintained at 27 degrees Celsius. Then what is the source temperature? Option A 750 degrees Celsius, option B 477 degrees Celsius, option C 203 degrees Celsius, option D 67.5 degrees Celsius. Now I will analyze the question. There is a heat engine and the working principle of the heat engine is Carnot cycle. That is, the heat engine will receive heat from the source and the heat engine will utilize certain portion of heat to produce work output and the remaining portion of heat will be rejected to the sink. So this is the working principle of this heat engine. So in this case, the heat engine rejects 40% of absorbed heat. That is, only 60% of heat is being used to produce work output and the remaining 40% of heat is being rejected to the sink. The sink temperature value is 27 degrees Celsius. That is, the temperature of sink is 27 degrees Celsius. So in this question, we have to find the value of source temperature. Now I will list out the given conditions. So the first condition is heat supplied to the heat engine from the source. That is, the heat absorbed by the heat engine or heat supplied to the heat engine is taken as Q1. So the second condition is heat absorbed by the sink or heat rejected from the heat engine is taken as Q2. That is, the heat rejected to the sink is taken as Q2, and Q2 is nothing but 40% of absorbed heat, which is 40% of Q1. So this 40% of Q1 is nothing but 0.4 times Q1. And the final condition is sink temperature, and the sink temperature is taken as T2 and the value of sink temperature is 27 degrees Celsius. So here the temperature value is in degrees Celsius. So I am going to convert it to Kelvin. To convert it to Kelvin, I am just adding 273 to this value. So we get 273 plus 27 degrees Celsius is 300 Kelvin. So this 300 Kelvin is nothing but the Kelvin value of 27 degrees Celsius. Now we will look into the solving technique. So in this question, we have to find the value of source temperature, that is T1. We know that the working principle of this heat engine is Carnot cycle. So we have a formula in Carnot cycle and the formula is 1 minus Q2 by Q1 is equal to 1 minus T2 by T1. So in this equation, the 1 in the LHS and the 1 in the RHS will get cancelled, and the negative sign in the LHS and the negative sign in the RHS will get cancelled. Therefore, we get Q2 by Q1 is equal to T2 by T1. We know that Q2 is 0.4 time, Q2 is 0.4 time Q1 and T2 is 300 Kelvin. Therefore, 0.4 time Q1 divided by Q1 is equal to 300 Kelvin divided by T1. So 0.4 time Q1 divided by Q1 is 0.4. So 300 Kelvin divided by T1 will be equal to 0.4. So now bring this T1 to the RHS and 0.4 to the denominator of LHS. We get T1 is equal to 300 Kelvin divided by 0.4. So 300 Kelvin divided by 0.4 is 750 Kelvin. So T1 is equal to 750 Kelvin. So this 750 Kelvin value will be converted to degrees Celsius. For that, just subtract 273 to this value. That is, subtract 273 to this 750 Kelvin. We get T1 is equal to 750 Kelvin minus 273, which is 477 degrees Celsius. So the value of source temperature T1 is 477 degrees Celsius. So option B is the right answer. Okay, so you can see here among these four options, B holds the value of 477 degrees Celsius. Thereby option B is the right answer. So friends, this is the method to solve this problem. If any doubts are there, please do comment in comment box. And remember to like, share, comment on our videos. And please do subscribe our channel, The Mechanical Engineers Theme. And don't forget to click the bell icon so that you will get the notifications for new videos. Thank you, friends.